Hello there, this is Wellington with PX5, and today I'll show you how to create multiple threads using attributes and priorities with PX5 RTOS. So in this video, I will quickly show you the APIs, then I'll run a 2-minute demo, and then I'll share some resources. But before we move on, did you notice the difference in the API names? Well, the first one is a traditional POSIX pthread API, which is also available on PX5 RTOS. Now the second one has the PX5 prefix. Why is that? Well, as we know, deeply embedded real-time applications will often require additional services. For this reason, PX5 RTOS provides optional extensions to pthreads, and these extensions are represented here with the PX5 prefix. So let's begin with the attribute init API. In order to use attributes, we need to create an attribute structure. So we can use it in the pthread attribute init call like this. Next, we can check for error codes. Once we have the attributes initialized, we can change them as needed. To do so, we need to supply the attribute structure that we created before, and we also need to define, in this case for the set priority, the new priority value that goes from 0 to 31. Remember that larger numbers equals to higher priorities. Finally, we can check the return for error codes. Note that these attributes we're setting here are only relevant when supplied to the pthread create API. Once this thread has been created, this set attribute priority can be changed for the next thread or even deleted without affecting the threads that we already created. Also, in this sample, we are changing the set priority by setting a new value to it. But priority is not the only attribute which can be modified using PX5 RTOS. So if you want to know which other attributes you can change, make sure to check our user guide manual. I added a couple of them here for your reference. Okay, it's demo time. As always, main starts executing and creating variables, thread handles, and the memory area. After that, in line 7, we start PX5 RTOS by providing a random number for pointer data verification. We explain what that is in a different video. Also providing a memory area and the size of that memory area. This will convert main into a thread running at the default priority of 16. And next, to create another thread, all we need to provide is, well, the handle to this new thread and the entry point for the new thread. So here we can see the child thread has been created, also with the default priority, and is ready and waiting to run. At this point, main yields, allowing child thread to run. Okay, so child is now running and it will increment its counter. By yielding, main has now been suspended and it is ready to run. So child yields back to main. So now let's create the higher priority thread. This will require setting up the thread attributes so we can specify a higher priority. So that's what we're doing here on line 15 with the pthread attribute init call. With the attribute structure created, now we can specify the priority. In this case, we are specifying 30, which is higher than both main and child. There you go, set up here. Next, to create the higher priority thread, we'll be passing the handle to this new thread, the attribute structure, and the entry point for this new thread. Now, the moment this new thread with higher priority is created, it will preempt the ones running before. In this case, main was running. The moment it created this thread, it was preempted by it. Now priority thread is running and it will increment its counter. There you go. So priority now will sleep for one timer tick to give all of the other threads the opportunity to run. Also notice that this attribute structure is here and it's going to be sitting here waiting to be reused if needed. So back now to main. Priority thread is blocked on the timer, so you see here is blocked. Main is running again and will update its counter to 1 and it's going to yield. And since the priority thread is still blocked waiting on the timer, there is only one thread that is ready to run, which is the child one. So child is now running. It will yield. Main picks up, increment its counter, yield again. But at the same time, the timer interrupt will wake up the priority thread, which will immediately preempting child thread from running. Priority thread increments its counter and is now going to sleep again. Now back to child, which has been preempted before, so it now can resume. Okay, and that is the demo we have for today. If you want to get started or learn more, make sure to check our website at PX5 RTOS.com. You can email us with questions, requests for information, or a quote at info@px5rtos.com. As always, thank you for your interest.